As I've been trying to move my guitar building from a hobby to an actual business, one thing that I've been trying to do is really evaluate the cost of doing any individual part of the build process. When you buy a body blank, for example, it might be $85, but if you buy the wood itself and joint it and glue it together, it might only be $20. Another area that I found that's fairly expensive is if you buy pre-cut fret wire, it certainly is convenient, but it's about 3 times more expensive than if you buy fret wire yourself, bend it and cut it. The thing about going to a process like this is you need a specialized tool to bend the frets so that it has a radius over top of the fretboard. One thing to keep in mind about that tool, though, is depending on where you buy it, it might be close to $100. And you can see over my shoulder, here, I have a 3D printer. And so what I wanted to do is see if it was possible to 3D print a FretBender. And so in this video, I'll just very briefly talk about the 3D printing process, show how it's assembled, and then I'll actually demonstrate whether or not the FretBender works, and then, depending on that result, how I might end up changing the design. And so without further ado, let's get into it. I found the 3D model for the FretBender on Thingiverse, which I'll link to in the description. There's 11 pieces as part of the model, which I printed in 3 separate steps. The step that's showing now are the body pieces that make up the majority of the FretBender. I chose to make my FretBender two-toned green and black. In both cases I used PLA. The settings are in the Thingiverse directions. I believe I used 30% infill, but for the most part, other than the pieces where you have to insert a nut, the process is very straightforward. The assembly wasn't too bad, though sometimes I had a little bit of trouble inserting nuts into the printed pieces. But here you can see I just used my bench vise to force the nut into place. Same thing here, just a little persuasion with the hammer to get the bushing to fit over the bolt. This part here is one of the parts that printed with a nut inside of it, and once I got the bolt threaded into the nut, it was just a matter of tightening it up. These bearings are the key parts for how the FretBender works. It requires having 6 of one type of bearing and then 2 of another type of bearing. Again, the exact model numbers are in the Thingiverse instructions. Once again, I'm struggling a little bit to put a nut into the plastic. I believe there's some sort of shrinkage that goes on as the plastic cools. Perhaps I was supposed to do this, while the pieces had just come off the printer and were still warm, but either way, the bench vise forces it in there, and then, we can go ahead and put some more bearings on and put the triangle piece on. Here are the other type of bearings I'm talking about that have a lip on them, and you put them in there, and this holds the big bolt that holds the wheel that actually takes the fret through and bends it against the other bearings. This step was a little bit out of order. You'll see me actually taking the handle off again when I need to do a different part of the installation process, but nevertheless you can see the FretBender starting to come together. This was the hardest part to figure out. There's a couple of slots there to accept a nut, and then the bolt goes through the top holes like you see, but it was actually very difficult to get that in there. I both used pliers, and then I also used a nail punch to try and get the holes aligned. So here I'm taking off the handle, as I said, to give me more space to actually squeeze the nuts into their holding slot. With the nuts in place and the handle back on, now we can put the adjuster piece onto the fret bender. And you can see I'm pushing the bolt through that piece, and this is what bolts it to the rest of the bender. One tip that I can add here is make sure you don't torque the bolts down too tight. This, in the end, is still plastic. I tightened them too far, which actually warped the plastic a little bit. The bender wasn't working as well as it could have, but when I backed them off, things worked a lot better. Now I'm threading in the long threaded bolt that goes along with the 2 threaded wheels. This is what changes the radius of the bend that you put into the fret wire. And with the wheels in place, now you have a completed fret bender. Off camera, I trimmed off the excess of the bolt that's sticking at the top. With everything assembled, now we can see how well it works. The way this machine is set up, if you take the dial and spin it in the left direction, if it's facing you towards this side, it makes the radius flatter. And then as you move this dial, you can see this gap will start to open up. That is bringing the wheel closer to the bearings, which will make a tighter radius. There are 2 holes in the bottom here where you could screw this into something. You could just use it by hand. But since I have my workbench here, I'm just going to clamp it into the workbench and then bend some wire. So you can see with this loaded up here, there's a little bit of a crack, not a crack per se, a little bit of a space that can hold the fret tang. And so you can imagine it's going to ride along this bearing here. And so if we put this in right now, and we load this up, it's really not that tight, and so if I bring this through, it probably won't put any radius. Yeah, it won't put any radius at all. So what I need to do here is actually to bring the wheel further down, and then we can bring the fret wire through. This style here, you actually push up to press against the fret in the middle. And this is to fix a problem with the classic design where you get to the end of the fret and it doesn't bend the wire. In this case, by having the bearing all the way up, you can put a consistent curve on the entire length of the fret wire. And so what I'll do is I'll just screw this down here, take my wire out first. And this is the type of thing where you probably want to do a couple of passes until you get really comfortable with it. And so just tighten this up a little bit. It's probably a little hard to see here, but I put the most minimum sort of radius in. So again, we'll just tighten this down. And now you can start to see that there's more of a radius. In my case, most of my guitars have a 12-inch fretboard radius, and so I want something a little bit rounder than that. And so again, we'll just keep turning this dial down. And make sure that we feed the tang through so that the bend is in the proper orientation. Okay, I'm going to put this on the workbench here. You can see, the wire has now been bent, to have a radius in it. If I just take this neck that I've been working on, and when I put it down on the fretboard, it's approximately the right radius now, exactly for the fretboard. So I want to bend it just a little bit further. Okay. So now you can see I might have even gone a little bit too far, but we've got a nice rounded piece of wire. I can trim it off, and then when I go to put it into the neck, it will have a nice curve so that when I pound it in, the fret tangs will go sideways a little bit, which really anchors down the fret into the fretboard. So what are my final thoughts about this design? First off, this design was provided on Thingiverse, and so just from that perspective, there's nothing to complain about. If I were to buy one of these commercially, as I mentioned, it might be north of $100. This is probably $15 worth of material at most. It really doesn't take that much filament to print this out. The bearings themselves are what costs most of the money, and then at least for me in the United States, this uses metric hardware, so that takes a little bit of effort to find. But overall, the design absolutely works, as demonstrated by this piece of fret wire here. It went from being flat to a nice semicircle. And so I don't plan on making these commercially. I think what I'm going to do is just make a couple of them on demand, trade them with other enthusiasts. If I were to actually try and do something with this commercially, I think I would revise the design to use less metal hardware. I probably would make it a little bit smaller, just things to make it more cost efficient for myself. But overall, I couldn't be happier that I was able to 3D print one of these. But even more importantly, as I go on, I can probably reduce the cost of fretting a guitar by a third. Saving $10 on every guitar quickly offsets the $15 or whatever this cost me to make. And so if you have a 3D printer, I would highly recommend going to Thingiverse, getting the design. I'll put the design link in the description. And yeah, another successful project. Thanks for watching.